Welcome to geometry. This is unit 4, um, test practice kind of thing. I'm just making this video to help you prepare for the test. I'm gonna pick some of the problems from the study guide that you were given, and hopefully this will help you. So the first problem that I'm looking is number 1. You're asked to find this angle right here, given this is 123. Given that this is 123, and you're asked to find this angle, how would you do that? Well, looking at the question, I'm seeing a few things. I'm seeing two parallel lines and a transversal cutting through them, like crossing through them. And now when I'm seeing that, automatically it comes to my mind alternate interior angles, alternate exterior angles, corresponding angles, vertical angles, all of those good things. I have that, right? I know this stuff, so I can use that here. But I see that 123 is outside these two parallel lines. It's outside those two parallel lines, right? So when I'm thinking of that, I'm thinking it must be exterior angles or corresponding angles that I'll be using. Alternate exterior angles or corresponding angles, something like that in that line, right? Looking at this, I'm seeing that 123 is alternating to the missing angle. You see, this one is facing this way, this angle is facing that way, the other way. So it's alternating. Exterior because it's outside, so they must be congruent because of alternate exterior angle, right? If you were asked, say, find this angle, well, then you will be using vertical angles, right? These two are vertical to each other. So this would be 123 because of vertical angles. If you are asked, I don't know, this angle, right? Then this forms a straight line, straight angle. This line right here forms a straight angle. So if this is 123, then this is 180 minus 123, which is 57, I think. Well, let's say that you were given 57 degrees and you're asked to find this angle right here. Well, given that this is 57 degrees, right off the bat, I'm thinking of this angle being interior because it's inside. Now I'm checking to see if I'm looking for an alternate angle, which I am. In this case, I am looking for an interior angle to the one that's 57. So this will be 57 degrees because of alternate interior angles. Okay. Cool. Then I'm looking at this one. Question number 3, and you're asked to find A, B, C, and D given certain things. Well, I'm seeing two parallel lines, right? So right off the bat, I'm thinking interior angle, exterior angle as well. I'm also seeing a triangle. So now I'm thinking of using the fact that interior angles of a triangle add up to 180 in the future. Like I might be using that in the future. Okay. So let's just see. I know that this is 57 degrees. Well, this is inside these two parallel lines, right? So I know I'll be using alternate interior angles. And that angle that's alternate to this one is A, which is also 57 degrees. Same thing, same reasoning. 64 is, what do you call it? It's alternating interior angle to B, 64 degrees. Now I have a triangle. I can find my D by subtracting 180 from 57 and 64, right? And I'm just using a calculator, 180. I don't know if you can see this. Minus 57 minus 64, and I got 59. So D is 59. Next thing you ask to find the C. Well, I can see that there's a straight angle. This one's a straight angle, right? So I can subtract 180 from 64 to find my C, which is 116 degrees. Right. all you're doing right now is using all of those facts that you learned about parallel lines, straight angles, triangle. It's a combination of all of those things, right? Cool. The next question that we are looking is this one right here. Given a triangle and a line extended by the sides of a triangle, and you're asked to find certain angles. Well, the key point for this one was that, hey, if you're giving me a triangle and if you're giving me two angles out of it, I can find my third angle by subtracting 180 from each angles, right? So 180 minus 90 minus 31. 180 minus 90 minus 31. Well, that's 59 degrees. Once I find this angle right here, I can find this one easily because it makes a straight angle. So I can subtract 180 from 59 to get that missing angle, which is 121, right? These questions, you can find them, find the missing x, right? Using the fact that, hey, interior angles are up to 180, and then these two angles are vertical angle because they're formed by the same vertex point. So these angles must be equal as well. So you have to, again, it's all about you using the information that you have, right? Okay, base angle theorem basically says this. In an isosceles triangle, say PQR, if QR is my base, if QR is my base of the triangle, then angle Q and angle R are congruent, and line segment PQ is congruent to line segment PR. Let's look at this. In triangle ABC, isosceles triangle ABC, my base is BC, AB is x plus 2, BC is 2x plus 3, right? AC, you're trying to find AC. Well, AC is congruent to AB. I know that. That must mean that this is x plus 2. And that's all you can find, right? That's all you can say, that AC is x plus 2. That's all. What if the question was asking this? Hey, what if AC is your base, right? You want to say AC is your base? Let us say, here, let me create a question, okay? In triangle PQR, if QR is your base, PQ is x plus 2, PR is 2x plus 3, find x. Well, now you can set them equal to each other and solve for x. Because these two are equal, because QR is my base, right? Every single time when you're given a question like this, draw the diagram. It becomes so much easier. Just draw and then it becomes really easy. Same thing, if you're given two angles, right? If you're given these two angles, you can set them equal to each other and solve for x. Or you might be given, for example, here, you might be given a different angle. You know that this is x, this one is x, so this must be x as well, because opposite angles for the sides that are congruent are also congruent. So if this side is congruent, then this angle is congruent to this angle. So you have two x's plus 40 equals 180, right? You can solve it that way. Alrighty. Next question. I'm just doing question number 3 again. Three. You're asked to find x and y, or x plus y in this case. For you to do that, you have to find x and y first. Just fill out the information. That's the very first thing you should do, is just fill it out. Jm is 4x minus 2. Jk is 3x plus 10. Mn is 10y minus 6. And nk is 8y plus 24. Given this information, you're trying to find x and y. Well, you're also given that Jn is your perpendicular bisector. That means this is congruent to this. You can find y by setting this two equal to each other, right? You can find y by setting this two equal to each other. But what about this two? Do you know if these two are congruent? Yes, you do. You have side, you have an angle. You also have a side that's congruent to itself. You see, by side angle side, triangle JMN is congruent to triangle JKN. That means this side is congruent to this side. And you can set them equal to each other and find your X and Y. Cool. Next, sides of parallelogram. Opposite sides and opposite angles of a parallelogram are congruent, right? So that's basically what you're using right now. If you're given a parallelogram, say this one right here, and you're asked to find x, you know that these two are congruent to each other because they're opposite sides. So they're congruent. Set them equal to each other and solve for x. Cool. Second here. We also know that diagonals of parallelogram are bisect each other. They bisect each other. So the point where those two diagonals meet, they cut each thing in half. That means this is congruent to this, and this line is congruent to this line, right? It cuts in half. So if you're given US is 120 is 22, just 22, US is 22, you're trying to find VE, TE, UE, and SE. What's up with that? You can find, given that US is 22, you can find UE and ES by dividing 22 by 2. So you get 11, 11, this one is 11, and this one is 11. And then VT is 28. So that must mean that this is 14 and this is 14. Right? You just have to know these things that, hey, if you're given a parallelogram, opposite angles are congruent, opposite sides are congruent, diagonals bisect each other, and adjacent angles are supplementary. Let's talk about that. Angles of parallelogram. What do I mean by adjacent? Angles that are right next to each other, they add up to 180. So angle D plus angle C is 180. That's what supplementary means, right? So angle D is basically 62 degrees plus the missing angle that you're trying to find. And angle C is 55 degrees. Well, you have an equation and a missing variable, right? And you can solve for that. Okay? Okay, cool. The next question I want to talk about was this question number 2 in proofs of parallelogram thing. When writing a proof, you're saying something, right? You're saying a statement, but you have to give me a reason why. You have to give a reason why, right? To back up your statement, I guess, to support your statement. That's what reasoning means. So let's start with this. You're given that ABCD is a parallelogram, right? So ABCD is a parallelogram. Why? Well, it's given angle DA, draw that, okay? Angle DAC, this angle is congruent to angle BCA, this angle. Why? Well, you can look here. What are the possible things? Alternate interior angles. Well, is that alternate interior angles? Yes. So it's basically that one. I'm just going to name this statement 1 and make this one. Is the second statement true as well because of alternate interior angles? Let's talk about that. Angle ADB, this angle, is congruent to angle CBD, this angle. Yes, same thing, alternate interior angles. Cool. Line segment DA, so this line is congruent to line segment CB. They are congruent. Why? Well, this shape is parallelogram and DA and CB are opposite sides, so they are congruent. Well, that's this one. Opposite sides of parallelogram are congruent. 2. Now they're saying that triangle DAE and BCE are congruent. Why? Take a look here. You have an angle, you have an angle, you have a side after that, you have a side after that, and then you have another angle that are congruent. That must mean it's an angle side angle postulate. Okay, They have to be connected. You cannot say that it's angle, angle, side, because there's a side in between these two angles that you're talking about that's common. You cannot say angle, angle, side. It has to be angle, side, angle, right? So it's angle, side, angle postulate. And then they're saying DE is congruent to EB and CE is congruent to EA. Well, that's CPCTC, CPCTC, right? Basically, if you're given a proof, make sure your proof is like if you're given a proof and you're asked to find, say, this or a reasoning, just read the proof before that, see what they're talking about, and then give a reasoning, right? If you had not looked at the proof, if you had just done that, you could have said this angle, angle, side. I have two angles on the side, two angles on the side. Or is it two angles and a side? See, it makes a huge difference. Okay. The next thing I want to talk about is the sum of interior angles of a polygon. We have a formula. It's 180 times n minus 2. That's the sum of a n-sided polygon. So for example, if you're given, say, a hexagon, and you have to find, hey, what's the sum of each angles inside a polygon? Well, how many sides does a hexagon have? 1, 2, 3, 4, 5, and 6. 6. Plug in 6 for n, and you get 180 times 6 minus 2, which is 180 times 4. I have no idea what 180 times 4 is. Let's see. 180 times 4, 720 degrees. Let's say then they ask you, hey, what is each interior angle? Each interior angles in this. Well, you can then take 720, divide by the number of angles that you're gonna split them into. Well, 6, and that is 120 degrees. Well, each one gets 120, right? So that's each interior angles measure. Okay. If you're given sum of certain angle and you're asked to find the n, right? What you can do is, let's say this. Hey, sum of a polygon is not sum. Each interior angle is 90 degrees. Find me what kind of shape it is, right? Well, what you can do is 90 degrees equals 180 times n minus 2 all over n. You're trying to find n, and then you can solve for n. Multiply n on both sides, you get 90n equals 180n minus 360. You can add 360 after that, and then subtract 90. So you get 360 equals 90n. So n equals 4. It's a four-sided shape, or a quadrilateral, four-side quadrilateral, right? Okay. Next, exterior angles, right? We know that given any shape, an exterior angle of any polygon always adds up to 360. So if you're given a shape, let's talk about hexagon, and you're asked to find each outside angle, what would be the angle that would be each outside, I guess, for each angle? With there, how many are there? 1, 2, 3, 4, 5, and 6. Divide that by 6. Each one will have 60 degrees if it's a regular polygon. Same thing, if you're given a measure of an exterior angle and your angle outside, and you're asked to find how many sides are there, you can undo it, right? It will be 360 divided by n equals each measure. Let's say you're given 120, and you're asked to find what is n. Here, n will be 3 because it's triangle. Okay? Exterior angle is 360. One thing, exterior angles always 360. Interior angles, you have to find it by using this formula, 180 times n minus 2 over n if it's each interior angles. If it's just a sum, don't use this n. You just 180 times n minus 2. That's for the sum of interior angles. Okay? Cool. One other question that I want to look at was this one right here. If you're given hey, if you're given point A, which is 2, comma 1, point B, which is 6, comma 4, point C, which is 4, comma 3, of a parallelogram, and you're asked to find point D, how would you do that? Well, first of all, graph it. Okay? Graph it, you will have, this is what it will look like, right? A, B, C, and you're asked to find D. Well, I know that D will be in this side somewhere here. So, and it must be congruent to AB. The side must be congruent to AB and parallel, right? Well, if it's parallel, I know the slope must be the same. The slope must be the same, and the distance must be equal. Start with this. How many x values am I changing from point B to point A? See, I'm going from C to this side, so I must go from this to this. You see? Then the question is, how do I know if I'm going from point B to point, like, how do I know that? Well, A, B, C, D, you will be drawing your parallelogram like this, A, B, C, D. That's why I know my point D will be on this side, somewhere here. It won't be on the other side of C because it will not make sense. It will not be a parallelogram after that. Well, my question is this. If this is 6, how many x values am I moving to get to point 2? How many x values from point 6 am I moving to get to point 2? Well, 4. So move 4 units to the left in point C in terms of x values. Well, if I'm moving 4 units to the left, I'm going from 4 to 0 here. That's my x value for point D. Now, let's talk about y value, right? Well, how many values am I going from 4 to point 1? Well, from point 4 to point 1 is 3 values, right? In terms of y-axis. So I will do that. 3 down, 1, 2, 3 down. So I'm going 3 units down. 1, here. 1, 2, 3. This is where my point D is, 0, comma 0. And I can connect it. I know this quadrilateral looks weird, but it is a quadrilateral. That's what makes it a quadrilateral. Point D at 0, comma 0. Okay? All I did was, because my point D will be somewhere around here, I knew my point B and point D are connected. I just found the distance, how far they are in the x value and the y value, and I subtracted that in terms of C, like Cx value, which is 4 units to the left, and 3 units was down, so it became 0, comma 0. All right, this is the end of the video. I hope this helps. Have a great test.